So the cylindrical shell idea really, on some of the problems, will make it a lot easier, because when we have that axis not being the x or the y axis, when we rotate about that, the other line, this will actually give us a little bit easier method. So pretty much where this formula is coming from is, if I take, I'm trying to draw it, if I take something that's on here and I put this like function here, all right, and I take a little chunk of it, if I rotate this about the y-axis, that makes a cylinder. All right, so what we're doing here is we're taking each little piece of the cylinder as we go out, and we're kind of building the volume by increasing the size of the cylinder as we go. So if you want to see some fancy pictures, we can look in the book and show you some fancy pictures. If I had this stuff electronically from the book, I would take some of those pictures up and put them up here and show you. I wish I had that. I could pull up some other things if we need to talk about it a little bit more and show you. Pretty much what happens with this, and this works if it's with respect to the y-axis also, so x and y can be interchangeable. I kind of drew a picture where we would have a y there. All right, so if I drew a picture with an x, it would look kind of like this. We'd have our function rotated about, well, I'll just draw it here, about the x-axis. If I rotate this way, and we have our cylindrical shells going the same direction as what we're rotating, the same axis of rotation. We get a radius by figuring out how far away we are from, so this is our radius that goes here. All right, depends on how far apart we are from what we're rotating around. Our height is going to be our function, so that's kind of like, so this is kind of like the surface area formula a little bit, right? You remember circumference? I said the wrong thing there. 2 pi times the radius. If I take 2 pi times the radius, and then I multiply by the height, that gives me kind of, if I hold a piece of paper up, that pretty much gives me the thickness of this paper if I'm holding it up. All right? The dx part means I'm starting really small and I'm filling up layer upon layer of paper inside the cylinder. And that gives me the volume, because it gives me how much stuff is inside. So conceptualizing this is probably harder than actually doing what we're doing. All right. I did go ahead and type some of the stuff out that he had in the book. This is like the very last thing before the problems in the section, where he's like, all right, these are the steps you kind of need to take to get these problems done. It's not necessarily about memorizing the formula. Those processes are good. But if we're going to do this, we need to be able to figure out what region we're revolving, so we sketch that. And then you got to decide if you're going to go with x or y for our integration. So if the region has a well-defined top and bottom, and we're kind of rotating about the, if we're revolving about the x-axis, we're going to do x. If we're revolving about the y-axis and we have a nice left and right boundary, then we're going to rotate and do that with integration of y. So again, based on what we're revolving around and our variable, we need to determine our method. So today, the method I'm going to show you is going to be the cylindrical shell method, because of how we're revolving. We did the disk method and the washer method before based on how we're revolving. You'll see sometimes you can use any of those methods, but today I want to show you just doing the one so that we get comfortable kind of practicing that, and then we'll pick some of the other ones. So when we're doing this, we need to label stuff. So if you're doing disk or washers, you need to label the inner and the outer radii. If you're doing cylindrical shells, you figure out the radius and then you figure out the height. And then we're going to set up the integral and evaluate. So the integral part, evaluating that's the same kind of stuff every time we've done the integrals. So the problems I picked for you to work on for homework are just like what I'm going to do today. They're explicitly just using cylindrical shells. All right, so you don't have to pick the method on these. It tells you to use that method. So we've got a region bounded by y equals x squared, and then y equals 2 minus x squared, and we're evolving about the line x equals negative 2. So the first step, sketch a picture out. Let me draw my picture real quick. So, got my little graph here. We know that y equals x squared goes up like this. And the 2 minus x squared actually starts up here at 2 and goes downward. So our region that we're rotating is here. And then those match up at negative 1, 1 and positive 1, comma 1. And our line x equals negative 2 is what we're revolving around over here. All right. So we're taking this little piece here in the middle and spinning it around. It would almost look like a donut if you spin it around. All right, if you want a visualization of what this shape would look like, it would kind of look like a donut. All right, so to do the cylindrical shells, we need a radius. So our radius is going to be between whatever x value we have and negative 2. All right. So if you have a positive x value, you can kind of take that number minus x, or you can do x minus that. So we're going to do our radius being x minus negative 2. So that's just x plus 2. All right. Then our height's going to be, let me try to change colors up here real quick. Our height's going to be between these two pieces up here. This is going to be our height of our shell. All right. So our height, which function's on top? 2 minus x squared's on top. So I'm going to do 2 minus x squared minus that x squared. All right. So I'm going to do 2 minus x squared minus x squared. And now we have to set up our integral. All right. So
free ticket to sit in the student block at the game on Saturday needs to report to the cafeteria.
we do 2 pi times our radius times our height. Now I'm going to go ahead and simplify my height. I didn't do that yet. 2 minus 2x squared. And we're integrating from negative 1 to positive 1. Okay, so the radius is going to be the distance. So since we're doing with respect to x here, from whatever x value we're at. So in this case, I drew my little line over to the y-axis, but that's x being 0. My radius is going to be whatever my x value is minus negative 2. So if I'm over here at 1, my radius would be 1 minus negative 2, which is 3. Well, if I'm over here at this negative 1, my radius would be 1, because negative 1 minus negative 2 is 1. So my radius is however far I am from x equals negative 2. So in this case, it's going to be whatever that x value is plus 2. That'll give me my radius. All right? It's a good question. So do you understand where the height comes from? Because once we have those two things, once we have our radius and height, we're just doing 2 pi times the radius times the height. And we're integrating between negative 1 and positive 1. All right? So it's kind of like doing the area between these two curves, between negative 1 and positive 1, and then we're doing the 2 pi and the x plus 2 just to get the volume from that. All right? So in order to do this, we pretty much have to multiply these two things together. We'll pull the 2 pi out front since it's a constant. And then we'll just evaluate the integral. All right? So our volume is going to be 2 pi, and then I'm doing the integral from -1 to +1. And then if you do x times 2, you get, I'll write it out up here, and then I'll write it out in order, 2x. And x times -2x squared is minus 2x cubed. You got 2 times 2, which is plus 4. And then you got minus 4x squared. So I know some people like to have that in, order of the degree, and so I'll just go ahead and rewrite it down here. -2x cubed minus 4x squared plus 2x plus 4. And we're doing that with respect to x. All right. So, you want me to keep working it out? So once we get that part down, the hardest part is getting it set up right and understanding how to set it up right. So I got -2x to the third, so that's going to give me -2/4, or -1/2 x to the fourth. And then I've got 4, and I got x squared, so that's going to be minus 4/3 x cubed. Plus, since I've got just an x, I'm raising that x to the second power, and then I'm going to do 2 divided by 2, so I got plus x squared, and then plus a 4x at the end, and I'm going between -1 and +1. Alright, if you plug in the 1 and the -1, several things will cancel out actually as you go. This x to the fourth, this x squared, evaluated at 1, and then subtracting the -1 will actually go away, and you'll end up with -4/3 plus 4 minus +4/3 minus 4. So, and I'm skipping some steps here because I'm running out of room to write. Alright, so you'd end up with 2 pi, and then you get a -4/3 here, minus another 4/3, so I get 8/3, -8/3. And then you get a 4, a +4, because the 1 times 4 is 4, minus a -4, which gives you an 8. Alright, so we're plugging the 1 and the -1 in to get these numbers. And then, when you simplify this down, that's 24/3 minus 8/3. Alright. Where did I go wrong? I feel like I wrote something down wrong. Should be 32 pi over 3 for the final answer. I think I wrote something down wrong. I think that should be a positive. Alright, so the hardest part, I would say, is figuring out your radius and your height and getting that set up. And then the rest is just doing the integrals like we've been doing. Alright.
On the radius,
What?
say on the radius, why did you subtract that? I think it is x minus -2,
So-
why would it just be x plus -2?
So, in order for this to be 1, right? This is 1 away from -2.
Yeah.
So, in order for it to be 1, if I would put, what'd you say, x?
Yeah, like why wouldn't it be x plus -2?
X plus -2? If I put -1 plus -2, I would get 3 out, right?
Yeah.
And that's not 3 over here for this radius. So we have to think in terms of how far apart would any x value be from that -2. In this case, if I add 2 to a -1, it's 1 away. If I add 2 to a +1, it's 3 away, which actually checks out with what we did. So if I was over here at +2, then I would do 2 minus x to get the right spot. So you just have to kind of think about where you're going with what we're trying to do. All right. Yeah. So the same kind of idea. First step is to draw a diagram. So here we've got x equals y squared and x equals 4, and we're revolving about y equals negative 2. So are we going to do with respect to x or with respect to y here?
Y.
Chances are, with the way these are, with the way these are, we're going to do with respect to y. Because if we look at the graph, number one, x equals y squared goes like this. X equals 4 is over here. And we're revolving about y equals negative 2. So that's our, wait, I drew that line backwards. Sorry. So we're revolving about a line at the bottom. I drew it wrong that time. So actually, it should go right through that point. So y equals negative 2. And that point is 4, negative 2. And this point is 4, positive 2. So we're taking this region and rotating about the line y equals negative 2. So since we got a nice right bound being 4, we got the left-hand side being y squared. Since we have that, we're going to do with respect to y. All right. So what would our radius be? Our radius is going to be whatever our y value is minus negative 2. So it would be y plus 2 for our radius. All right, in this case, y plus 2. If I put in a negative 2, I get 0, which is what I expect from my radius here. If I put in a positive 2, I should be 4, and it is 4. So y plus 2 is our radius. Our height is going to be between these two functions here. So our height is going to just be 4, and then take away the y squared. Go ahead. So our integral is just going to be, for our volume, would just be, we're going from negative 2 up to positive 2 of 2 pi times my radius times my height, and then the dy is why we are going to have volume here at the end. All right. And I think the worst part is getting them set up and understanding which one you need to use, which method. So since this says cylindrical shells, this is going to be how you set them up. All right, just to save some time, I'll do another one and just set it up again as well. All right. If you want me to work one of these out, I'll work it out for you. So, again, once you get it graphed, you set up the radius, you figure out what the height is, and you plug them in. So here, if we draw the graph, we got y minus 1 squared, which is a little different, but not much. We got y equals 5. We got x equals 9.
Very, very.
Again, you start by setting up the picture. You figure out the radius. In this case, it's going to be 5 minus the y value. and my height is going to be 9 minus y minus 1 squared. All right, and then you just plug them in. Set them up and evaluate. All right. So like I said,
I was going to ask, is the radius just the difference between where you're rotating it from and the function? Or
so
to the axis?
To whatever y value we have in this case. So our function is here with the y minus 1 squared and the 9. My radius is going to be however far, since I'm doing with respect to y, whatever slice I'm at. So I could be here or I could be down here. That would be a y value. So my radius would be however far I am from 5 to that. So in this case, it's 5 minus that y value. So and it checks out here. If I do 5 minus 4, I get 1, which is how far away I am there. If I do 5 minus negative 2, I get 7, which is how far away I am on the graph to that point. So it's however far away you are from wherever you're rotating. So sometimes you're going to do the number minus y, sometimes you're going to do y minus that number, depending on if it's positive, you do the number minus y. If it's negative, you're going to do y minus the number. So it kind of flip-flops either way, depending on if you're positive or negative. But it's always going to be whatever that number is, either plus y or minus y, kind of a deal. You just kind of have to think through your head and think through it, which way makes the most sense, gives me a positive radius, and you'll get it right. Let me go ahead and stop this.